In the previous session, we spoke about factorizing of equations, and we basically did one. Okay, I want to do one more of those where we got factorizing coming into it. Let us say we have this equation here. Just check. We have example. Okay, this is type A, which is factorizing. Okay, so remember, this is all about type A, which is factorizing, which we do anyway as a matter of course, right? Factorizing, we say 6 sine squared x. 6 sine squared x minus sine x minus 2 equals 0. Now, that is a straightforward quadratic equation. We look for highest common factors. If there are, take them out. Okay? Then we look for difference of two squares. No. Therefore, it is a straightforward quadratic equation. And we factorize that as follows. 3 sine x minus 2. And over here, 2 sine x plus 1. Plus 1 equals 0. Okay, and we then come to sine x equals 2/3 and sine x equals minus a half. Do you remember in every trig equation, what was the first thing we did? We isolate the trig function. Trig function or expression. Can you see by factorizing? That's what we have done, right? Now we can solve normally. We say, therefore, reference angle is going to be equal to arc sine of 2/3, and reference angle is going to be arc sine of minus a half. Okay, I get my reference angle here of minus 30 degrees, and over here, my reference angle of 41,81. Okie dokes. Next, what did I do? I said next was the type. Type. This is a sine. And this one is also a sine. Therefore, I have got the following. Therefore, theta, in this case, x, equals 41.81 plus 360k. Okay, and I've got to write a bit small. My apologies about this, but I will run out of space if I don't. Sorry, not theta. X, because I used an x, equals 180 minus 41.81 plus 360 degree k. And we've got theta, keep writing theta, x, because it's x in this case, minus 30 plus 360k. Okay, and x is 180 minus 30. Minus 30. Okay, whoa. Sorry. Okay, 180 minus 30 plus 360 degrees k. Can you see there? It's a negative angle, so we end up with x equals 41.81 plus 360k. X equals 138.19 plus 360k. X equals minus 30 plus 360k. And x equals 210 plus 360k. All degrees, okay? And let's just put in the degrees, like so. And k element of z, okay? Now let us say, all right, that's about as heavy as the factorizing gets, okay? So we look for highest common factor, we take it out. We look for difference of two squares, we take it out. We look for some trinomial quadratic, factorize, put them both equal to 0, and therefore you get your answer. Remember, if you've got a sine causes, you can't divide through. So my next one is going to be type B. B is going to be sine theta equal to cos theta types. All right? And in this case, we've got this. Let us say we've got 5 cos theta equals 3 sine theta. Okay? Now, only now can we divide by sine or cos to create tan. Okay? There's a reason for that. Yes, you are allowed to divide by 0 to create tan, because 1 over 0 is infinity and tan can handle that. It's got an asymptote there. Okay? So it's an acceptable thing to do. Let's put it that way, shall we? So I'm going to divide by cos. Therefore, I say, okay, 5 is going to be equal to, divide both sides by cos theta. Okay. So 5 is going to be equal to, 5 is going to be equal to 3 tan theta. Therefore, tan theta is going to be equal to 5 over 3. Now I can go reference angle is equal to angle whose tangent is 5 over 3. And I get an answer there, 59,04 degrees. Okay, therefore, my theta is going to be equal to reference angle plus 180K. 59.04 degrees plus 180K, like so. Oh, and K, element of Z. So the type is where I can divide through by cos, okay? All right? Or sine, well, only cos really, to create tan. What if they gave us this then? Cos squared equal cos x. Example. Okay. Cos squared x equals cos x. No, you can't divide through there. You're not creating tan, right? So, cannot divide by cos x because we are not creating, creating tan. Okay? So what would we do? Quite simple. We would have this. We would have it, and we take it to the other side. Cos squared x minus cos x equals 0. Factorize. Cos x comes out, leaving us with cos x minus 1 equals 0. Therefore, cos x equals 0 and cos x equals 1. And then we'd solve those. Okay? In the normal way. You just go with those. So where we have a sine cos types, we can do that, right? Type C is using cofunctions. All right? What if we have this? Cos 2x equal to cos of x minus 30 degrees. Okay? Both are cos. All right? Both of these are cos. Just have a look here. Cos and cos. Therefore, I can use the standard method. right? What would I say? I would say, therefore, reference angle is going to be cos of x minus 30 degrees, which is going to be equal to x minus 30 degrees, right? That's my reference angle. And then I say type. It's a cos type. Therefore, my general formula, theta is plus minus RA plus 360 degrees K. Remember, we have to know this. Okay, you have to memorize that yourself. Therefore, I can say that theta, but theta in this case is 2x again. 2x is going to be equal to the RA, x minus 30 degrees. Can you see what I did? That's my R. RA contains the x. It's kind of, the one is inside the other one here. Okay? So therefore, I can follow the recipe, but I just wanted you to see that, can you see there's an x inside it? Which doesn't matter, because I say x minus 30 plus 360k, and 2x is equal to minus x minus 30 degrees plus 360 degrees k. Now let's simplify. Therefore, 2x is equal to x minus 30 degrees plus 360 degrees k. I take this x across to the other side and it becomes a minus, and I end up with x is minus 30 degrees plus 360k. Correct? What about here? I say, okay, 2x is equal to minus x plus 30 degrees plus 360k. That becomes then 3x, because I take it over and I add it, equals 30 degrees plus 360 degrees k. Now I divide through by 3 to get my x. X is 10 degrees plus 120 degrees k. Right. So those are my final answers. Just let's recap it. What did we have? We had a cos and a cos. Now, important, I want to put it in red here again. That was a cos and a cos on both sides, right? And the x is, I can't split that. Well, there are ways, but I can't split that up yet. Okay? So how do we deal with it? Apply the same rules, and you end up with an x in your reference angle. And then you just basically take the x to the other side. And you group like terms, don't you? Look here. Okay? You take it out the brackets and you group like terms. That's how you do those. Now, my question now is then this example. Oops. I always go back to black pen. Yes, look at this one. Here's an example for you. Cos of 2x equals sine of x minus 30. Oh, right? We can't do that because now I'm going to end up with that's a cos and that's a sine. Cannot do it. They're not the same. I cannot take cos to the minus 1 of sine. Okay? That doesn't exist. Arc cos of sine, if that was just a number, yes, I can do it. But it's not. It's got an x in it. So I'm completely messed up now. So how do I do this? I use cofunctions. I say cos of 2x is equal to, I change that to cos of 90 minus x minus 30 degrees. Can you see? Let's just recap this here. Sine. I want this to be cos. because then I can apply the recipe that I used above. Correct? This is quite a difficult section of the work. So if you're a bit confused at the moment, that's cool. Just recognize that you've got cos, okay? You've got cos here, there, and you've got sine on that side. And to boot, that and that are totally different. Okay? They're totally different things. Therefore, if I've got that, I can't divide through by sine. If I had cos 2x sine, yeah, then I could divide. Okay? But I can't here because the thing in the brackets is different. Okay? So there's nothing the same in this. So the only way forward is to use the cofunctions. Okay? And the cofunctions tell me to change the sine to a cos using that. Remember that cofunction? Okay, and you can see that I have done just that now. Now what have we got? We've got, I can do this, can't I? Because I can say that is cos of 90 plus 30 is going to be 120 degrees minus x. Now I can take reference angle is going to be inverse cos of 120 minus x, right? Which is going to be what? Okay. The cos of the inverse cos is 120 degrees minus x. All right, that's my reference angle. Then what's my next step? My next step was decide type. Type is it's a cosine. Okay. Remember the type comes from the left-hand side, okay? It's a sine or a tan or a cos on the left-hand side, okay? It doesn't matter which way around you do these mode of interest, but this is the easier way. And therefore we have cosine. Therefore, theta is equal to plus minus RA plus 360 degrees K. This I remembered, correct? Therefore, 120 minus x must be equal to, oops, sorry, my bad there. I'm a bit ahead of myself, okay? 2x must be equal to that. 2x must be equal to, here's my RA, 120 minus x, okay, plus 360k. And 2x must be equal to minus 120 minus x plus 360k. Expand the brackets here, must be equal to 120 minus x plus 360k. X goes to the other side, 3x is equal to 120 plus 360k. X is going to be equal to 40 plus 120k. Okay, like so. And on this side, it's minus 120 plus x plus 360 degrees k. All I'm doing is moving the brackets, take the x over, and it subtracts. Minus 120 degrees plus 360 degrees k. Okay? Now, if you wish, you can go back and check your answer. You can put in 40 degrees or minus 120 degrees, okay? And you will get the correct answer. As I said, these are not easy, okay? They're not. Okay. Now let's have a look at a different one. Let's have a look at this. Cos of a half x. Cos of a half x equals sine of x minus 30. You say, okay, fine, cool. That's a sine cos type. It was the type B that we did, wasn't it? Oh, it would be, except for one problem. This is not the same. Not the same, therefore, not sine theta equals cos theta type. It's not a sine theta equals cos theta type because that's not the same as that. If it was, we could divide through by it, but it is not. In other words, to create tan, but it's not the same. Okay? Therefore, it is a cofunction type. Okay? It is a cofunction type. So I'm just watching because this is quite a long one. It's a cofunction type. Therefore, I have to make it cos and cos on both sides, because then I can take the inverse cos. So I write that is cos of a half x, okay, equal to, what I actually did is I reversed them, okay. I reversed it, and I said like this. It doesn't matter which way around you do it, just by the way, equals cos of a half x. Now I'm going to change that cos to a sine. I chose to do this because the previous one I did the other way. This is going to be sine of 90 minus a half x. Okay? All right. Can you see? Why did I do this? It's just simpler. But in essence, you could have done it the other way around. It makes no difference whatsoever. Okay? Then I say, okay, therefore now I can say I've got both sides the same, sine, sine. Therefore, I can take inverse sine of both sides. Therefore, my reference angle is going to be sine to the minus 1 of sine of 90 minus a half x. And that sine and that one cancel out, right? They don't. You can't divide through by sine. It's just the opposite function. Like squaring a square root. Same concept. Okay? That becomes 90 minus a half x, like so. Now, therefore, I've got it. Once I've got my reference angle, I can continue because I now choose type. Type is sine. Therefore, I say x minus 30 degrees, right? Remember, is equal to 90 minus a half x plus 360k. And x minus 30 degrees equals 180 minus the reference angle. There it is. Okay. Here's the RA. There it is. Plus 90 minus a half x plus 360 degrees k. Where did this x minus 30 come from? Let's recap that. You say, oh, hang on, Kevin, where did you get the x minus that? Remember, the x minus that comes from, that was in behind the function. It's this that goes down there, isn't it? Is equal to what you plug in for the RA. Remember from the previous examples? Now I can solve it. Now it requires a little bit of mishmashing, and I say, okay, put that equals there. Eventually I get 3 over 2x. 3 over 2x is equal to 120 degrees plus 360k. And this side I get that is equal to 90 minus a half x plus 360 degrees k. Okay. Excuse me that I often leave out the degree sign. Then I'm going to take that to the other side. Therefore, x is going to be equal to, and that becomes a half x. Just make it nice and tidy. Therefore, a half x is going to be equal to 120 plus 360 degrees k. Can you see? What I did is I took that half, okay, across, all right, plus a half x, minus, plus, silly me, okay, plus a half x, I took it across, and it became a minus x minus a half x, there it is, x minus a half x. Let me just do it, let me actually just do it. I have x minus a half x, and that 30 became positive and added to the 90. That gives me a half x equal to 120 degrees plus 360 degrees k. Therefore, x is going to be 240 degrees. Why? Because I'm going to multiply it all by 2 times 2. And remember I told you, always write it down so that you make sure you get everybody. Every single person has to be multiplied 720 degrees k. Okie dokes. Let's have a look at this character here. This character says to me, I'm going to be 3 over 2x is that. Now I must multiply by what? Remember, I must multiply by 2 over 3 times 2 over 3 times 2 over 3. And hey presto, we end up with x equal to 80 degrees plus 240 degrees k, and those are my 2 answers. You can back substitute any one of those in and have a look, and you will find the answer. Okay. Right. Now, the next section is going to be doing a sine squared plus cos squared addition, and because I'm sort of running out of time, I'm not going to do that one right now. I'll do it in the next section in Trig 11, all right? But that section that we've just done is probably, it is by far and away the most difficult part of, I think, the syllabus, because you have to, but just remember, go through those things. Is it a straightforward factorization, highest common factor, difference of 2 squares, quadratic, cubic, or can I group items? In essence, you're trying to get things in brackets equal to 0 so that you can simplify it and then solve for x that way. The next, is it a sine theta equals cos theta, or sine of 2x minus 15 equals cos of 2x minus 15, in which case you can divide through by cos to create tan, okay? If it's not that kind, okay, if it's not, then you have to basically move the sine or the cos to the other side, factorize and put those equal to 0. Remember, you can only divide through by cos to create tan, otherwise not. The last type is using the cofunctions that we just did. The cofunctions are when I have got the sine of some angle equal to the cos of a different angle. Remember, sine of x equals cos of 3x minus 15. They are different things. So I can't divide through by this one, all right? It's not possible. They are different expressions. Therefore, I rewrite the cos or the sine in terms of the other function to get a sine and a sine, or a cos and a cos. Then I can take the inverse function. Right? And remember, you're going to get an x on the left and an x on the right, or a theta on the left and a theta on the right. That time you bring functions, you bring group-like terms, add, subtract, and you get your answers based upon that. Okay. Yes. The next one I'm going to go on with, I'm going to do the square identity, which is not as difficult as the one we've just done. Cheers. Do practice 1 or 2 of these. I'm hoping that that the cofunction thing doesn't come up for you guys, because it is difficult to spot. Maybe the one way is to say, heck, I've run out of anything to do, therefore it must be a cofunction thingy, if you can't see it. Okay? Cheers. Have a good one. Bye.